Greetings, ladies and gentlemen. This is Freddy Matanzela and welcome back to my YouTube channel. So in this video, we'll be looking at inverse trig functions. So now we'll be looking at if I'm having an inverse, for example, of the inverse of cos x. So to find the derivative of it, we need to find the derivative of f at x over a squared minus f at x squared under a square root. So it will be negative. Then for sine, the inverse of sine x will be equals to f at x over a squared plus minus. So in this case it will be minus f at x squared under a square root. So we can also look at the inverse of 10. So the inverse of 10, if we want to derive it, we need to find the derivative of f at x over f at x squared plus a squared. So now let's look at the following example. So being said that, we need to find dy dx of y is equals to inverse of 10 x plus 1 over 2. So first we need to identify our f at x. So in this case our f at x will be equals to x plus 1 over 2. So to find the derivative of f at x, we'll say f prime x is equals to, I would like to separate this our f at x because of we are having a common denominator. So it will be x over 2 plus 1 over 2. So now the derivative of it, it will be 1 over 2. So we know that the derivative of x is 1. So therefore our f at x prime is 1 over 2, because when you differentiate the constant, 1 over 2 will get 0. So therefore, since now we know, or we have identified, our f at x, and we also have identified our f prime, so we can go to our equation here. So we can go to our equation and substitute what we have. So we first said that dy dx is equals to f prime over f at x squared plus a squared if we are differentiating the inverse of 10. So therefore now our f prime x is 1 over 2 and our f at x is x plus 1 over 2 all in squared plus 1. So therefore now what we need to do, we need to remove the brackets. So we have to distribute 2. So we'll have 1 over 2 over x plus 1 all in squared over 2 to the power of 2 is 4 plus 1. So therefore we can say 1 over 2 over, now we can look for our lowest common denominator for what? For our denominator. So in this case it will be 4. So 4 goes into 4 how many times? Once. So we'll have x plus 1 squared plus, so 1 we know that is always over 1. So if it's always over 1 goes into 4 how many times? 4 times. So 4 times 1 is equals to 4. So therefore, now what we need to do, we need to simplify. So simplifying this, we will say we'll say 1 over 2 over, or we can write it to make our life simpler, we can say 1 over 2 divided by x squared plus 2x plus 1 plus 4 is over 4. So now someone will ask themselves, what did we do here? So what we did here we distributed our x, our squared. So therefore now we'll say 1 over 2 multiplied by, we're gonna write the reciprocal, 4 over x squared plus 2x plus 5. So therefore our answer will be 2 over x squared plus 2x plus 5. The reason is that 4 over 2 is what? Is 2. So this is our answer. So this is the derivative of 10 arc. Example 2. So now this one, it will be a bit complex. So I want to highlight some important things. So let's say y is equals to cosec, or the inverse of cosec, sec x cubed. So in this case, if you could look at your formula sheet, you don't have the formula for you to derive cosec. So the best way to do is to remember the basic, that sine x is also the identity of 1 over cosec x, and cos x is the same, or it has the identity of sec x. Then we also have 10x, which is 1 over cot x. So now we're going to apply these formulas. We're going to apply this information, so it helps us to solve this equation. So now where I see arc cosec, I'll put arc sine. The reason I'm putting arc sine, because 1 over cosec, it has the identity of what? Of sine. So therefore now let's come to our problem here. Our f at x will start to change, since now we change cosec, so that means we also need to put the inverse of our f at x. So in this case it will be 1 over sec x squared. So looking at the formulas we just written now, 1 over sec is what? Is cot. So therefore we can say cos x cubed. So now since we have this, we can start to solve our equation. So to solve our equation, we'll say f at x is equals to cos x cubed. So therefore our f prime x will be equals to, the derivative of cos is negative sine x cubed multiplied by, what's the derivative of x cubed is 3x squared. So therefore, to write it in a neat form, we'll say a negative 3x squared sine x cubed. So now, since we know our f at x and we know our f prime x, we're going to apply the formula above. So the formula said, if we want dy dx, then if you want dy dx for inverse of sine, we're going to have f prime x over a squared minus f at x squared bracket. So now we're going to substitute our f prime x, which is negative 3x squared sine x cubed over 1 minus our f at x is what? Is cos x cubed squared under a bracket under a square root. So therefore now what we're going to do, we're going to simplify. So to simplify the following, we're going to say y is equals to negative 3x squared sine x cubed over a square root 1 minus cos squared x cubed. So we can substitute this with an identity. Remember, when you're doing your metric, we said sine squared x plus cos squared x, they are equals to 1. So therefore, if you make sine the subject of the formula, you will have sine squared x equals to 1 minus cos squared x. So therefore, where we see 1 minus cos squared x, we're going to substitute sine. So therefore, we'll have a negative 3x squared sine x cubed over a square root of sine squared x cubed. So we will say a negative 3x squared sine x cubed over, what's the square root of sine squared? Is sine x cubed. So therefore, our final answer, we will say sine x cubed cancel sine x cubed, then we will be left with a negative 3x squared. So this is our final answer. I thank you.